In the last video, we saw how to solve a typical investment style question. In this video, we're going to take a look at the other type of application for sequences and series, and that's loan repayments. These sorts of questions are usually pretty lengthy in the exam and usually have a stack of marks allocated to them. But if you're well practiced, you can easily nail even the harder questions, and since these questions are quite mechanical, they're basically free marks in an exam. To understand how to do these questions, we need to understand how loan repayments work. In this question, Georgina borrows $5,000 and pays $100 at the end of each month, and she's charged interest at 1.5% per month. Let's draw a quick timeline so we can visualize what's happening. Now you can see the intervals where she pays. Between each of these intervals, the loan will be accruing interest and growing in value, and then at the end of the month, a repayment is made to reduce the value of the loan. In the next interval, this new balance will then start to accrue interest until the next payment is made, where it's then reduced. The loan value will then again start to grow and is then reduced, and so on. So mathematically, we use a compound interest formula to see what value the loan grows to and then subtract the loan value. In this case, after the first repayment is made, the value will be 5,000 times 1.015 minus 100. This component represents the loan value after one period, and this component the repayment. Now this whole thing is a new loan balance after the first month, and this will accrue interest and grow over the second month. We find its value again by using the compound interest formula, where this new value is the principal amount and the compounding period is 1. So we just multiply this whole thing by 1.015 and we get 5,000 times 1.015 squared minus 100 times 1.015. Then we subtract off the loan repayment and we get the end of month balance as 5,000 times 1.015 squared minus 100 times 1.015 minus 100. We can find the end of third month value by multiplying the end of second month value by 1.015 and subtracting 100, we get 5,000 times 1.015 cubed minus 100 times 1.015 squared minus 100 times 1.015 minus 100. We can actually now see a pattern start to form. For each of our periods, we always have 5,000 times 1.015 to the power of something, and that power is always the same as the period we're looking at. Next, we have a geometric series where the loan repayments are multiplied by the interest, and the highest power in this series is one less than the period we're looking at. This series always ends in just the latest loan repayment with no interest component. And you can see this is actually the case for all the terms we've looked at so far. You can pause the video here to investigate the expressions we've come up with so far. So that means we can follow the pattern and extrapolate it to find the balance after the 8th repayment and answer part A. So we'll have 5,000 times 1.015 to the power of 8, since this power needs to be the same as the period. Then we'll have minus 100 times 1.015 to the power of 7. 7, since it's one less than the term that we're looking at, which is the 8th term. Then minus 100 times 1.015 to the power of 6, then minus 100 times 1.015 to the power of 5, and all the way down to minus 100 for the latest repayment. We don't have to write all the terms since we'll be using the geometric series formula to evaluate this series. What I'll do before we do that is to factorize out minus 100, and I'll reverse the term so that it's easier to add together. And we get this. Now we can evaluate this using the geometric series formula. Our A is 1, our R is 1.015, and we have 8 terms since we'll start at a power of 0 and go up to 7, minus 1 divided by 1.015 minus 1. Now if we plug this all into a calculator, we get $4,789.18. So that's part A. Now for part B. As you may have noticed so far, there's a fair bit of algebra work and there's more to come in part B. So let's dive in. we want to find out how long it will take to pay off the loan. So what I'll do is I'll write out an expression for AN. So this represents how much we'll be owing after n repayments, and we just need to work out what n will be. Now after the nth repayment, what will happen is that the loan balance will become 0, because now we've paid off the loan, so we can equate our expression to 0 and solve for n. What I need to do is to simplify the series down using the geometric series formula. We do this in the same way as we did for part A, except the number of terms will be n rather than a number. So I'll go ahead and just do that. Okay, from here it's some hefty algebra work, but nothing that should be too unfamiliar. I'll speed through this part and you guys should pause the video at the end and just follow through my working. Now I've gotten to the stage where I have 1.015 to the power of n is equal to 4. What I'll do is take the natural log of both sides, and using the log rules, I'll bring the power of n to the front and I get this. Now dividing the ln 1.015 across to the right hand side, I can solve for n and I get n as 93.1 months. And that's that. The steps will be more or less the same for all loan repayment questions, so now it's just a matter of practice.